I'm going to start out defining a random walk a little bit differently from how I've defined it before. So let me see if you can recognize what the difference is. Start out with step, random choice between -1 and 1. Then I'm going to define a walk using nest while list. And what's my function? It's going to be keep repeatedly adding a step. So variable by # plus step and starting at 0, and I'm going to continue until my value is exactly equal to n. And then that's when I stop, when it's equal to n. So let me run an example of this and see if you notice what the difference is. So walk 5, let me do a couple more. Okay, here's one where you should be able to tell what the difference is. Before, when we defined random walks, we said stop when you get a distance of 5 from the origin. So stop if you get to either +5 or -5. That's if n is 5. But in this case, I said only stop if it's equal to +5. If it's equal to -5, like it is here, then just keep going. So that's the big difference. And I want to study how this changes the way random walks work. So as an example, let me make a table that contains 200 of these random walks, continuing until it hits the value of 20. So this is going to be a list of lists, what's made. Let me call it my table. And make sure you put a semicolon at the end, because if it's trying to print out some of these really long walks, then that takes much more time and might crash your computer. So let me evaluate this. And in my tests, it's sometimes taken quite a while, so let me pause the recording, and then I'll start it again when it's finished. It's finished running now. So remember, this my table that I just defined, it's supposed to be a length 200 list of lists, where each list is one of our random walks. So for example, say I were to look at my table, double brackets 121. So this is supposed to be one of the 200 random walks in there. So this is a very big random walk. It has length over 24,000. So let's ask, what's the average length? So how can I do that? Well, let's make something called length table. And how should we do that? Let's go through every list inside of my table. So let me just call it for every list inside of my table. Okay, list is just a variable name that I've chosen. And let's look at the length of this list. Okay, so here are the lengths. Let me hide them with a semicolon. And let's look at what the average is. So the mean of length table. Here it is, and if I want to see a decimal value, I can put it inside this capital N. So the average length, it's crazy, the average length is 899,880. If instead of going to 20, I was going to plus or minus 20, like we did when we did random walks before, then the average that we'd expect would be around 20 squared, would be around 400. So we can see how different this value is. So let's ask how many, so what's the count inside of length table? How many of these lists such that, oops, I shouldn't have called it list, should have called it n, because inside of length table, those aren't lists anymore. Now these are just numbers. How many n's are there such that n is bigger than 100,000? So there are only 10 that are bigger than 100,000, but still somehow the average of these 200 numbers is close to 1,000,000. How is that possible? Well, that must mean that the biggest one is very big. So what's the maximum in length table? So the maximum one is 160 million. What if I wanted to know where it occurs? Well, then I could do what's the position inside of length table of this maximum value. So it's at the 170th random walk that I get this gigantic length over 100 million table.